Hey guys, welcome to my channel, Sangupta's Creation. I'm Sangupta, your host and your coach, and today we'll be doing the exercise of the chapter Life Process. Electricity. Yes, now I hope you all can see this. Okay, so I think we should start answering the question and answers. So I hope you can see the page, and the first question in here says that a piece of wire of resistance R is cut into five equal parts, and these parts are then connected in parallel. If the equivalent resistance of this combination is R, then the ratio of R by R is, the options are 1 by 25, 1 by 5, 5, or 25. What would be the answer? See, it is said that the resistance is cut into five equal parts, which means that the resistance of each part is R by 5. So we know that each part is connected to each other in parallel. Hence, the equivalent resistance can be calculated as 1 by R equals to 5 by R plus 5 by R plus 5 by R plus 5 by R plus 5 by R. Means 5 by R, we are plussing it 5 times, which gives us what? 5 plus 5 plus 5 plus 5 plus 5 by whole by R, which is equals to 25 by R. So you see, R by R equals to 25. So the ratio of R by R dash is 25. So the answer to this So the answer to this is D. The answer to this is 25. Next, which of the following terms does not represent electrical power in a circuit? Okay, so the options are I to the power I square, basically I square R, or IR square, or IR square, or VI, or V square, V square by R. Okay, so the answer for this would be option number B, I R square. But why? Because as we know that electrical power is given by the expression P equals to VI. So according to Ohm's law, V equals to IR. So we can substitute the value of V, which is IR, in P equals to VI, which gives us P equals to IR into I, which is I square R. So similarly, from Ohm's law, we know that I equals to VR. So if we substitute this I equals to VR in P equals to VI, then it gives us V into V by R. So V square by R. So this is the answer. So the answer to this is IR square. Option number B. IR square. Okay, next question. An electrical bulb. An electrical bulb is here said to be is rated as 220 volts and 100 watt. When is it operated on 110 volt? The power consumed will be, what will be the power consumed? Will it be 100 watt? Will it be 75 watt? Will it be 50 watts or 25 watts? So let's see. The answer, we have to do this. Basically, the energy consumed by an appliance is given by the expression we have just learned, that it is given by P equals to VI, which is also equals to V square by R. So the resistance of the light bulb can be calculated as R equals to V square by P. So if we substitute the values here, that R equals to, 220 square by 100, it gives us 484 ohm. Then even if the supply voltage is reduced, the resistance remains the same, so hence the power can be consumed as P equals to V square by R. So P equals to 110 square volt by 484 ohm, which is equals to 25 watt. So therefore the power consumed when the electric bulb operates at 110 volts is 25 watt. So it is 25 watt. Next, question comes that two conducting wires are of this same material and of equal lengths. Are of equal lengths. So, and equal diameters are first connected in series and then parallel in a circuit across the same potential difference. So, the ratio of heat produced in series and parallel combinations would be, either it would be 1 is to 2 or 2 is to 1 or 1 is to 4 or 4 is to 1. So, the answer to number 5, the answer to number 4 would be that, let's take the the resistance is series and the resistance is parallel. So let RS be the equivalent resistance of the wires in series and RP be the equivalent resistance of the wires when connected in parallel. So for the potential difference V, the ratio of the heat produced in the circuit can be given as heat produced in series by heat produced in parallel. So in series we have v square by r by the resistance is series into time, that whole amount total by v square by resistance is parallel into time. So it gives us resistance in parallel by resistance in series. So the equivalent of resistance of resistors connected in series is R plus R, which is equals to 2R, and the equivalent resistance of resistors connected in parallel is 1 by 1 R plus 1 R, so it is R by 2. So hence the ratio of the heat produced in series and parallel combinations would be heat produced in parallel by heat produced in series, which is equal to R by 2, R by 2 whole by 2R, right? So it becomes R by 2 into 1 by 2R, right? So it becomes 1 by 4. So the ratio of heat produced is 1 is to 4. Okay? So the answer is, it is 1 is to 4. 1 is to 4. Next, how is the voltmeter connected in the series connected in the circuit to measure the potential difference between 2 points? The answer to this is that to measure the voltage uh, between any 2 points, the voltmeter should be connected to in parallel between the 2 points. Okay, you can write it down. I just write the points here, that I just write in points that the volt the voltmeter should be in parallel between the 2 points. Okay, next question comes that a copper wire has diameter of 0.5 millimeter and resistivity of 1.6 into 10 to the power, okay, just a second, 10 to the power minus 8 ohm meter. So what will be the length of this wire to make the resistance 10 ohm, and how much does the resistance change if the diameter is doubled? Okay, so first we know that the area of cross section is, okay, let me write. So you know the area of cross section is, how it is given by, it is given by a, just a second, area. So it is given by area, which is now denoted by, which is now denoted by sorry, equal, a equals to, then a symbol here, which is a pi, I guess. How can I take a pi? Okay, I don't think here is a pi, but still we can see, we can guess. The font, I must find the symbol of pi, whatever, just leave it, it's pasting out. A equals to, uh, the value of pi is, I can't write here pi, so I'm writing the value of pi is, 22 by 7. So I'm writing the value of pi here and writing it as 22 by 7. So area is 22 by 7 uh, in total, then bracket, it is a diameter by 2 to the square, whole square. So this is the formula. Next is that, um, now let us substitute the formula. Okay, we can substitute the formula and we can get, just a second, if I can find it somewhere. Just a second. I think I have it here. So the area is given by this. Now the diameter is given as 0.55. Okay, I can. Okay, so given is the diameter, which is D equals to uh, D equals to 0.5. So then the resistivity we know that the resistivity is given by rho. This is the symbol here. I hope you can see. Okay, so we can say that we can the length of the wire let be L, and we have just learned that the area is A equals to pi. A equals to pi into D by, this is wrong, D by 2, D by 2, in this and 2. Okay, the formula of this is resistivity formula is that R equals to rho into L by the area, which is equals to this. So it gives us that for rho R equals to this. After calculating it, as you can see here, we get L equals to 122.7 meter. Okay, so this is the answer, that it is 122.7. Now, what did the question ask? This is only the this asked if what will be the length of the wire if its resistance is this. So the length of the wire would be 122.72 meters. This would be the length. Next question, the part question says that how much does the resistance change if the diameter is doubled? So as you can see that if the diameter is doubled, the new resistance would be 2.5 ohm. Why? Because we know R is directly proportional to 1 by d square. So if the diameter is doubled, then the resistance will be 1/4. So hence the new resistance hence the new resistance is 2 ohm. Okay, so this is the answer. Let us write the answer here, answer line here. The answer says that the length, first is the length of the wire to make its resistance 10 ohm, to make its resistance 10 ohm, resistance 10 ohm, comma, the length of the wire, length of the wire is 122.7 meter. And another question that is asked here is the diameter diameter would be 2.5 ohm. Okay, next what do we have? Next we have is number 7. What are the values of what the values of current I flowing is given resistor for the corresponding values. Okay, uh, values of the potential difference V across the resistors are given below. Plot a graph between V and I and calculate the resistance of the resistor. So, as you can see, I don't think. Let me see if I can. Yeah, this is the total, the table that is set in the corresponding values of the volt and I. And what will be. I hope it does. So the answer, I don't think I have the this thing voltage thing, but still I'll help. I can't plot them. If I can, I'll try to. Just a second. Okay. So I hope you can see. So these are okay. From the first, I am showing you the answers. This is the answer of number 1. This is number 2. This is number 3. This is number 3, which I'm highlighting. Those are the question, and the answers are also given corresponding, uh, respectively. Next is I hope you can see number 5. Then we have number 6. The answer to this is this. Now we were doing the answer of number 7, right? So this is that it has said to plot a, so this is the answer that this will look like this. Okay, next let's move on to the next question, which okay, so this is the plot. I've plotted this graph between V and I, and now the question says to calculate the resistance of that resistor. So, as we know that the slope of the line gives the value of resistance. So the slope can be calculated as I by R, which is BC by AC, which is 2 by 6.8. So to calculate R, we have R equals to 6.8 by 2, which is 3.4 ohm. So the resistance of the resistor is 3.4 ohm. So this is the answer. Okay. Okay. Next is number 8. So question number 8 says, so question number 8 says that when the 12-volt battery is connected to connected across an unknown resistor, there is a current of 2.5 mA in the circuit. So find the value of the resistance of the resistor. So the value of the resistor, we are using here the Ohm's law. It can be given as, we already know, using, we are doing this sum using Ohm's law. So first of all, how should you do a sum? Using Ohm's law, comma, sorry, where is the comma? Okay. So now we know that using Ohm's law, we can we know that R equals to V by T. We are going to use R equals to V by T. So basically, when we say I equals to V by T, what we have to do? it comes as V. The value of V here is 12. So it is 12 by 2.5, as we can see, 2.5 into 10 to the power minus 3 into 10 to the power minus 3. So it is equals to, comes as 4.8 into 10 to the power 4.8 into 10 to the power 3 ohm. Ohm. Or what you can write, you can write either this, or you can write 4.8 kilo ohm. You can either write 4.8 into 10 to the power 3, or you can write this. Before writing using Ohm's law, what you should write first is, you should always write the given data. First we will write given, which is what is given. The first one is given is volt, which is V. So equals to, it gives 12 volt. Next is what is given is the, sorry, I have written it wrong here. It not will be time, it will be I. It will be I. So it is given as I equals to, it is 2.5 this, or it can be written as 2.5 into 10 to the power minus 3a. Okay, so this is the answer. Next, we come to number 9. Now, number 9, what does it say? Number 9 says a battery of 9 volt is connected in series with resistors of 0.2 ohm, 0.3 ohm, 0.4 ohm, and 0.5 ohm, and 12 ohm respectively. How much current would flow through the 12 ohm resistor? So as we know that in a series connection there is no division of current, right? So to so the current flowing across all the resistors is the same. Okay, so first what we have to do is first we have to find out the equivalent resistance, which is R equals to 2 sorry 0 0.2 plus 0.3 plus 0.4 plus 0.5 plus 0 plus 12 ohm. So the answer to this would be 13.4 ohm. It would be 13.4 ohm. Okay, so this is the equivalent resistance. Okay, so after finding the equivalent resistance, what we will do from Ohm's law, what do we get from Ohm's law? We already know that I equals to V by R. So it gives us I equals to V by R, which also gives by 9 by 9 by 9 by 13.4, 9 by 13.4. Next it gives as so the answer after calculating it would be 0.671 a, 0.671 a. So this is the answer. Okay, how much current would flow? Is symbolizes here the current flow. Okay, next we have number 10. How many 176 ohm resistors, which is in parallel, the resistors in parallel combination, are required to carry 5A on 220 volt line? So first let us consider that the number of resistors is X. So the equivalent resistance of the parallel combination of R is given by 1 by R, which okay, so 1 by R. So now what it gives is, so by using Ohm's law, we can say that R equals to VI. Okay, let me write that. Let the number of resistors be X. So now we know that the number of resistors we take it by X. So the equivalent resistance. So it is as we know, 1 by R. It will be like the equivalent. This one is the equivalent. So it equivalent is x into 1 by 176. So it is x into 1 by 176, which is also equal to, which is equals to r equals to 176 by x. 176 by x. Okay, so we get here the equivalent resistance in the parallel series. Now what will we do? We will be using the formula of we will be using the Ohm's law. Ohm's law will be using. Uh, so after this, we know the formula R, very easy. R equals to V by I, which is equal. So now we substitute the values here. What does it give? It gives as, just a second, 176 by x equals to the V is given as 220 by, we have the we have the current here, which is 5A. So 220 by 5. Okay. Next, what we get is we find the value of x, which is equals to, if we cut this amount, 5, here will be 5 fours are 20 and 110. So it will be somehow 42. So it is equals to, let's take it as 176 into 5 into 5 by 220. So the answer would be, answer of x here would be 4. So the answer line would be the number of resistors, the number of resistors required are 4. So this is the answer for number 10. Okay, next we'll do number 11. Okay, so number 11 says that show how you would connect three resistors, each of resistance 6 ohm, so that the combination has a resistance of, first is 9 ohm and the second one is 4 ohm. Let us find out how we are going to do it. So first, if the resistors are connected in a series uh, of resistance, each of resistance 6 ohm, it gives us as so when they are connected, two resistors, first one is that two they are connected in parallel series. So in the first one, it gives us two of them are the 6 resistors. The resistance would be 1 by 6 by 6 plus 1 by 6 equals to 6 into 6 whole by 6 plus 6 in which is equals to 3 ohm. Now if the third resistor of 6 ohm and 3 ohm are connected in series, it becomes 6 ohm plus 3 ohm, which gives us 9 ohm. In case 2, when they are connected in series, resistance is 6 ohm plus 6 ohm, which gives us 12 ohm. If the third resistor 6 ohm is connected to the 12 ohm in parallel, then the total resistance is 4 ohm. So I'll give you the answer here. So this is the resistance. I'll write it down here. It is 1 by it is 1 by 1 by 6 plus 1 by 6, which is equals to gives us 6 plus 6, 6 plus 6 by 6 into 6. Okay, so this gives us as 3 ohm. Now if the third resistor is there, so this is the total answer. Okay, now let's move on to the next question, number 12, which says several electric bulbs are designed to be used on a 220 volt electric supply line and are rated 10 watt. How many lamps are connected in the parallel with each other across the two wires of 220-volt line if the maximum allowable uh, current is 5A? What will be the answer? Now we can, I hope you can see this. Okay, so we know that the resistance of the bulb can be calculated using the expression P1 equals to V square by R1, and R1 is equals to V square by P2. 1. Okay, so as you all can understand, we have to apply the concept of we have to concept of Ohm's law. Now I will tell you this in step wise. Okay, here is the explanation. So this first step is to find so the first step is to find the resistance for each of the bulb which we have done, and the answer is the resistance of each of the bulb is 4840 ohm, right? Next step is to find the equivalent resistance in parallel combination. So let us assume n as the number, the bulbs that are to be connected in parallel with each other. So therefore, their equivalent resistance can be given by 1 by R, which is equals to 1 by 4840 plus 1 by 4840 plus uh, that dash 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 n factors. So it comes as n by 4840. So the R equals to 48, because it is 1 by R which gives us n by 4840. So it gives us uh, so now it gives 4 equals to 4840 by n ohm. Now we have to apply the Ohm's law, which is resistance equals to volt by current, which is which gives us 4840 by n equals to 220 by 5. So from here, after we calculate, we get the value of n as 110. So therefore 110 lamps can be connected. Next, okay, so first question here says that a hot plate of an electric oven electric oven uh, connected to a 220-volt line has two resistance coils, and A and B, each of the resistance is there. So each of them has a 24 ohm resistance, which may be used separately in series or in parallel. So what are the currents in these three cases? Okay, we need to find about what are the three cases. So here also we have to use the concept of Ohm's law and equivalent resistance, which will help us. Now, equivalent resistance in both in series and in parallel. So, the first step, there will be steps. There will be in total of three steps. Of three steps we are going to do. Yes. So the first step says to find the current when, so it comes as to find the current when coils used to uh, you know, used separately. So it is, we know the value is V equals to I by R. So after calculating, we get as the value of I equals to 9.167 A. Next step is to find the current when coils are used in series. So we know equivalent resistance equals to R1 plus R2, which gives us 24 plus 24, which is 48 ohm. Then we have to find that V equals to I by R. Here the R is the equivalent resistance. So 220 equals to 48I, which gives us I equals to 4.583A. So this is number 2. After number 2, we get step number 3. In step number 3, it says 1 by, it is okay. Okay, 1 by equivalent resistance equals to 1 by R1 and plus 1 by R2, which gives us the equivalent resistance equals to 12 ohm. So volt equals to I by R of the equivalent resistance. Okay, so it gives us 220 equals to 12I, which after we calculate gives us I equals to 18.334A. So this is the answer for number 13. I hope you can see. Next, what we get is next is number 14. Now compare the power used in a 2 ohm resistor. Now, in a 2 ohm resistor, in each of the following circuits, a 6-volt battery, first is that a 6-volt battery in series with 1 ohm and 2 ohm resistors. And in the second one, we have to compare a 4-volt battery in parallel with 12 ohm and 2 ohm resistor. So what will be the answer? Okay, so we can easily see here that the potential difference is 6 volt and the resistors 1 ohm and 2 ohm are connected in series. So hence we can say that hence their equivalent resistance can be given as 1 ohm plus 2 ohm, which is equals to 3 ohm. It can be calculated using the Ohm's law, which is equals to I equals to VR, which gives us I equals to VR, which is equals to 6 by 3. So I equals to 2A. So 2A current will flow across all the components in the circuit. Now the power it wants the power, which gives us the power in 2 ohm resistor can be calculated as P equals to I square R, which gives us I square, which 2 square into 2, which 2 square is 4, so 4 into 2 is equals to 8 watt. Okay, so this is the answer. I have done with the first one and the second one too. Next, let us move on to number 15. Okay, please remember in the next class we are going to do the in-text questions of this chapter. Okay, so the next question, number 15, says that two lamps, one is rated one is rated to be 100 watt at 220 volt, and the other is 60 watt at 220 watt, are connected in parallel to electric main supply. So what current is drawn from the line if the supply voltage is 220 volt? Now, as you can see, that since both the bulbs are connected, the volt will be like this. Parallel, the voltage across each of them will be the same. This will be the same. So, therefore, so we can write easily that therefore the current drawn drawn from the line is equals to um, is comma 100 by 220 plus 60 by 220. It is plus 60 by 220, which gives us as the answer of 0.727. 0.727A. So this is the answer. Next we have number 16. Which uses more energy? A 250 watt TV set in 1 hour, or a 1200 watt toaster in 10 minutes? What will we do is we will first calculate it. So the energy consumed by the uh, electrical appliances is given by H equals to P into T, where P is the power of the appliance and T is the uh, time. So using this formula, the energy consumed by a TV of power ration 250 watt can be calculated as H equals to 250 watt into 3600 seconds, which gives us 9 into 10 to the power 5 joules. Similarly, the energy consumed by the toaster of power rating 1200 watt is given as H equals to 1200 watt into 600 seconds, which gives us as 7.2 into 10 to the power 5 joules. So from these two calculations, it can be said that the energy consumed by the TV is greater than the toaster. Just let's do this white. It looks awkward. So the answer to number 16, is this. Next question gives that an electric heater of resistance 8 ohm draws 15A from the service mains 2 hours. Calculate the rate at which the heat is developed in the heater. So the rate at which the heat develops in the heater can be calculated using the following formula, which is P equals to I square R. So if we substitute the values in the equations, we get P equals to 15 square into 8 ohm. So we get 1800 watt. So the electric heater produces heat at the rate of 1800 watt. So this is the answer. So this is the answer to number 17. Next is these number 8. Sorry, number 18. Okay. So the first question says that why is the tungsten used almost exclusively transition. So why is the tungsten used exclusively for filament of electric lamps? The first answer is that so the answer to this is that actually the resistivity and the melting point of the tungsten is very high. So due to its property, it doesn't burn but readily when heated. Electric lamps operate at very high temperature, so hence tungsten is a choice of metal for the filament of electric lamps. Next question is, Why are the conductors of electric heating devices such as bread toasters and electric irons made of an alloy rather than a pure metal? So the conductors of electric heating devices are alloys because of their high resistivity, and alloys have a higher resistivity than pure metals. So due to its high resistivity, a large amount of heat is produced when current passes through it. The answer is here. Next, why is the series arrangement not used for domestic circuits? So the answer for this is that the series arrangement is not used for domestic circuits due to because first point is that the overall voltage gets disturbed in a series circuit. So as a result, electric appliances may not get the rated power for their operation. Second point is that all of the connected appliances cannot be uh, operated independently if one device is defective. And next is that the third one is that the total resistance becomes large, and as a result the current is reduced. Okay, next we have number D, 18A. The question is how much or how does the resistance of a wire vary with its area of cross section? Now, as we know, resistance is inversely proportional to the area of cross section. When the area of cross section increases, the resistance decreases, and vice versa. So, this is the answer for number D. Next, we'll move on to number E. Now, why are copper and aluminum uh, wires are usually employed for electricity transmissions? First is that copper and aluminum are good conductors of electricity and have a low resistivity, because of which they are usually employed for electricity transmissions. Due to low resistivity, the power loses in the form of heat and are also significantly less when electricity is transmitted through them. So, this is the answer for number E. I'll show you all of them again. So, this is electricity. Sorry. This is number one. You can note down. You have. I hope you have note down. Please note down this all these answers in your in notebook, or so that you can prepare it very thoroughly. Or you can see my videos again and again. It's up to you. This is 2, 3, 4, 4 till 4. It is you know MCQs. Then we have the question and answers 5. Then here is 6, 6. Next is number 7. In number 7, these are the values. This is the the to plot the graph. They have said the question, and then they have said to calculate the resistance of the resistor. So this is the answer. Okay, next we have number 8, then number 9. Next, after number 9, we have number 10. then number 11, then number 12. I hope it comes in all one. Yeah, this is number 12. Then number 13 we have. Okay, next we have number 14. Okay, after number 14 we have number 15. These are all the answers. Okay, then after that we have number 16, then number 17, and then at last number 18. Okay, so these are the three. For number C, these are the three reasons. Okay, next we have, after C we have D, then E. Okay, so this is the end of our class today. Thank you and have a nice day. If you like my videos, please subscribe and like my channel, and please hit the bell icon so whenever I'm online, you can join and learn and many new things. Thank you and have a nice day. Bye bye.